All right, so today's example, we're going to talk about the difference of squares. So when we do that, before we actually look at the factoring technique of a difference of squares, let's actually multiply this scenario and see what happens. When I multiply it, I'm going to do our FOIL. So our first term will be x times x gives me x squared. And then I get the outside is x times 3, which is 3x. The inside will be negative 3x. And the last term will be negative 9. We collect like terms, and I get x squared minus 9.
And they cancel each other out.
Because these ones, exactly, that is a sweet thing. Now what do you think, what enables these two things to cancel out? If I look at these two factors here, what allows them to cancel out?
Okay. So we've got the same magnitude, the same number,
right.
But one's positive and one's negative, right?
Right, that's the key. They're opposite signs, positive and negative. So if that's the case, we should be able to go backwards. If we're given this, factor by this. And so we have what we call here, this is a square, and this is another perfect square, and we have a difference because it's subtracting. That's why we call it difference of squares. So when I look at this, I have to recognize that t squared is a perfect square, 49 is a perfect square, and they're subtracted. So if I compare this to that, well, I'm going to have a t in the front.
Yep, that's our t squared.
That's our t squared. And then the last two positions there.
Okay, so I know 7 times 7 gives me 49. And if I make one positive and one negative, then they're going to multiply to give negative 49. And when we do FOIL on that, they're going to nicely cancel out those t terms.
Right. Does it matter which one's positive and which one's negative?
No, doesn't matter which way around.
As long as you have one of each. Okay. So let's try this. Take a look at this scenario then. So,
Is 1 a square number?
it is. The square root of 1 equals 1. So that's a square root. So they're sometimes difficult to spot, but it works as well. So y and y?
Yep.
Square root of 1 is 1 and 1. Make one positive, one negative, and we are set.
Nice.
Okay, so if we're going to make a general formula, a squared minus b squared, that's the same thing as saying we have a and a, b and b, and then one is positive and the other is negative.
Okay, because b times b is b squared.
Right. All right.
Tricky. It doesn't really look quite the same here, but we have got two squares. We need to make that bit on the left a square, and the bit on the right a square as well.
Right, and if I recognize that 11 squared is 121, and 3 squared is 9, and 4 squared is 16, these are all perfect squares. So if I factor it, what's this first term going to become if I break it up?
So that's 11 over 3. And that's the first term in the second bit. So those two multiplied together give us our 121 over 9. And then we need z over 4. Z over 4, make one positive and one negative. And you can always FOIL it out, make sure it works.
Great. So I would like you now try this on your own and then show your teacher in class that you were able to factor that to 2 bits. Good luck.